Hello everyone, I'm CodeMath and in today's video we are going to talk about a problem. So here is a circle and I'm asking you what would it give us to cut the circle in half. This is what we are going to talk about in this video. Here I will cover the topic of fractions, development, and lastly, factorization. So firstly, fractions. A fraction is a number that represents a part of a whole number. Think of it as some kind of pizza you'll eat with your friends. I will use this perspective with circles. So here we will cut it in half, and this will give us 1/2 since we cut the number 1 in 2 parts. This gives us 1/2. But what does that notation mean? 1/2? So to explain it, the number on the top is called the numerator. It represents the number of parts you took. The number on the bottom is called the denominator. This one is the total number of parts you can take. Here is a demonstration. Here I can take 2 parts at maximum, but I will only take 1. So this is why I will write it as 1/2. We can also ask ourselves another question. Where are fractions on the real line? Actually, they are often between integers. So for example, 1/2 will make 0.5. When dealing with fractions, you often have to deal with decimals too. Now here are some things to know about fractions. First of all, fractions are the same thing as division, so 3/4 is the same thing as 3 divided by 4, and we prefer using the fraction notation because fractions take less place in an expression. Every integer can be written as a fraction. For example, 3 can be written as 3/1, because the 1 will not affect him. Also, if you remember from my previous videos, you know that division is a repeated subtraction. 16 divided by 4 is the number of times you'll need to subtract 4 from 16 to get to 0. In this case, you'll need to do it 4 times. Now, you might ask me, why are you telling me this? Actually, this is very important, because division by 0 is not allowed. Try to do 16 divided by 0. If you do such a thing, you will never get any closer to 0, and this is why the result is undefined. Now, on a lighter note, it is important to know that if a fraction has the same numerator and the same denominator, it will be equal to 1. Right now, the only thing we need to know about fractions is how we can manipulate them. For an addition, for example, if the fractions have the same denominator, then you can just add the numerator and go on. This is illustrated with the circles and will get 2/2, which is obviously equal to 1. But if the fractions have a different denominator, it can still be tricky. So here you will need to multiply the denominators and also multiply the denominators with the numerator. The same also applies with subtraction. You just have to replace the plus sign with the minus sign. I will really advise you to learn the formulas since it will simplify the work you'll have to do. As for multiplication, it is much easier because you just have to multiply the denominators between each other and the same for the numerator. Finally, for divisions, you just have to inverse the second fraction and then you multiply it all together. Here we have 1/2 divided by 1/2. So to proceed, we follow the formula and we inverse 1/2. We get 1/2 times 2/1, which is 2/2, which is 1. The last topic I will cover about fractions is simplification. Sometimes you'll deal with big fractions and you'll need to reduce them. How you can do that is to find a common divider. So here we divide both terms by 2 and we repeat, so we get 3 over 6, and then we divide everything by 3. This will give us 1 over 2, and this is the reduced form of our fraction. Now we cannot simplify it anymore, and this is how you simplify your fraction. Now I will cover development. Developing an expression is the act of expanding it as much as possible. One of the ways you can do that is through distributivity. Distributing is a way to simplify an expression by expanding it. Here, a is distributed to b and c, and this gives us a times b plus a times c. This can be actually useful to modify some expressions. And here we have a geometric interpretation of the formula. If you want to calculate the area of the rectangles, you have to use distributivity. As an example, let us develop that expression, 2 factor of 4 plus 8. So if we follow the formula, it will simply give us 8 plus 16, so 24. But we'll see later that we can reverse that operation. This can be done with factorization. Factoring is the reverse of development. It works by transforming the whole expression into a product. Here we have to factorize x squared plus x. But how do we do that? Actually, you just have to count the terms, then you have to find the common factor, and finally factorize everything. If we remember, the expression had 2 terms, x squared and x. Now, what can divide them both? If we try to find them a common factor, we can see that they can both be divided by x. We will use that property to factorize them, and this gives us x factor of x plus 1. So here is the end of the video. I hope you liked it and that you learned something. Don't forget to like and subscribe, and thanks for watching this video.